Hello, Math 1. I know we've done part of this lesson, but I'm going to go ahead and kind of start from the beginning with it. Sorry I can't be there today. So a geometric sequence is a sequence in which each term is found by multiplying, right? And we said or dividing, right? Now, the division is the tricky part, and we'll get to that, later on. But it's found by multiplying the previous term by a common ratio. Okay, so when we're given a geometric sequence, you start with your first term, then you multiply the first term by some r, then you multiply it by r again, then r again, then r again, and it keeps going and going and going. Well, a here is basically your first term. Okay, and r is your common ratio. Okay, so when I look at the common ratio, it's what you are multiplying or dividing by. Now the explicit rule, right, we're going to write it two ways. One is f of x equals a times r to the x, okay? But because a sequence doesn't always start at term 0, right, we're going to write this a way where as we move along, it gets a little easier. We're going to say a sub n, right, where n equals the term number. So it's a sub n times r to the x minus whatever n is. And this, will make more sense as we move forward. So the first example is asking, determine if the sequences are geometric. If they are, identify the first term in common ratio. Well, if I look here, I'm multiplying by 5 each time here. Therefore, yes, it is geometric. My first term is 1, and the common ratio is 5, because that's what I'm multiplying by each time. Now the next one, if I notice here, right, I'm actually dividing by 7 each time. So it is geometric, but what you have to understand is dividing by 7 is the same as multiplying by 1/7. So the first term here is 343, but we're going to say, right, we're going to say that we're multiplying by 1/7 each time. So the common ratio is 1/7. Okay. So now, in example 2, they want you to fill out the table. Okay, so I'm going to go ahead and fill out the table, both tables here for you. So what I basically did is inputted all the x values and got the output y values here. Okay, so what I want you to notice is, where does this number come from? Well, if you look at the table now that it's filled out, what is the common ratio here? I'm basically multiplying by 3 each time, right, to get the next term in the table, or the next y value, is easier to say. Here, I'd multiply by 2 to get the next y value in the table. So the common ratio, right, for this top table is 3, and the common ratio here is 2. So if you notice, right, the number we are multiplying by each time here is going to be that common ratio inside the parentheses being raised to the x power. So here's 2, multiply by 2, multiply by 2, multiply by 2. Next, what I want you guys to notice is this number here. This number here is basically the y-intercept for both functions, right? So that represents the y value when x is 0 both times. Now, what they want you to do is write a new explicit rule. So if I were to use another ordered pair, so say I was going to use, this ordered pair. If you remember what we said at the beginning, f of x equals a sub n times r to the x minus n. Okay, if we use this idea, this here is basically term number 1, and the output is 6. So when we go to write the explicit rule, we're going to say f of x is equal to, what is the value of the term, right? This here is the y value. That there is your y value that you are starting with, which is 6, times, right? What is my common ratio? My common ratio is 3. And then I'm going to do to the x minus what was the x value or the term value? That is 1. So if I wanted to write, say, another one and use this ordered pair, I could also say f of x equals 54, because that's the starting y value, times 3 to the x minus what x value did I use? The third x value. So this would be another explicit rule that could be used. So when I look at the second one, right, if I go to use, say, this ordered pair, I'm going to say f of x equals, what is the y value? 8 times, what's my common ratio? 2 to the x minus, what x coordinate did I start with? 1. And if I had to write, say, one more, if I use this ordered pair, the explicit rule I would use for that is 64 times 2 to the x minus 4. I'm starting with the x value, and the output for that is 64. Okay? So, if you are given the 0 term, that's the easiest one to use. So, if I look here, what is my common ratio here? My common ratio is 3. If I start with this ordered pair, all I'm going to say is my explicit rule is f of x equals, my initial value, y value, is 2 times my common ratio is 3 to the x power. If I subtract 0, x minus 0, just remember, is x, right? So that's why you don't even have to write the x minus 0. Now the next one, if I start with this ordered pair, first find your common ratio, times 2, times 2, times 2. So when I look here, I'm going to say f of x equals, my starting value is 4 times 2, but I'm going to say that this is, I'm using the first term, so it's x minus 1. Now, if I am given a choice to start anywhere, I always look for the 0 term. To me, that's just the easiest one to use if it's given. What am I doing here? Here I'm dividing by 3. Here I'm dividing by 3. But what you have to remember is dividing by 3 is the same as multiplying by 1/3. So f of x equals 4, my initial value is 4, right? Times, I'm basically dividing by 3, but multiplying by 1/3, so my common ratio is 1/3 to the x power. Okay. So now here, when I look at the next one, I notice I'm multiplying by 6 each time. So what is the first term? The first term is negative 12. So if I had to make this an ordered pair, it'd be 1, negative 12. The common ratio here is 6 because I'm multiplying by 6 each time. So the explicit rule would be f of x equals my first term is negative 12 times my common ratio is 6. I'm starting with the first term, so I'm going to use x minus 1. Okay, I'm not starting when x is 0, I'm starting when x is 1. In the sixth term of the sequence, all I'm going to do now is plug 6 into this. Negative 12 times 6 to the 6 minus 1 power is negative 12 times 6 to the 5th power. And if I do negative 12 times 6 to the 5th power in the calculator, you get negative 93,312. And the next one, find the first 5 terms of the sequence whose first 2 terms are 8 and 24. So 8 and 24, they tell us it's geometric, so here's the thing. What is this common ratio going to be? 3, right? So if I multiply by 3 again, 24 times 3 gives you 72. If I multiply by 3 again, I get 216. Multiply by 3 again, 648. Okay, so that is the lesson on geometric sequences. Go ahead and do the homework and let us know if you have any questions.